Goes down there again, then over there. Can I please? There it goes. Okay, it did that, and good. It did push that one, and the push behaved mostly as expected. Up, down. Okay, pushed that one. Behaved mostly as expected, or behaved as expected. Probably tried to do something vertical there. Go back. Back over. Okay. I feel reasonable about believing that the code is working. Okay. So, having done that, let's go ahead and let's also just not have that take 20 because otherwise, yeah. Now we need to handle the hard case. Else, oh no, we are vertical. This is actually tree-like. Okay. So, let's talk through the algorithm. First option. There's a wall anywhere above us. We cannot push. So what we need to do here is this is going to be kind of a little cheerful recursive check, I think. Okay. So all right. If I want to figure out if a box can move up, the question we've kind of got here is if we think about like we go think about pushing it up, we have to look at both the cells above it. And yeah, actually, you know what? Let's write a little function here. Bool can move in direction. Coord box half direction direction. And again, if the direction is left or the direction is right, return true. This is trivial. Like, I mean, maybe it can't, but like, okay. So now, if map at, actually, no, let's go ahead and do coord other half equals map at box half select implicitly. Oh no, sorry, switch. Goes to the other half of you, depending on what type of box half you are, is either the C plus 1 or the C minus 1, or underscore not supported exception. Don't call this with something that isn't a box. Error handling? What error handling? We're doing error handling for type safety, and that's it. Okay, so now we have the other half. We have 2 coordinates. So now we just need to ask ourselves here is we need to get ourselves, we have the, we're going to get ourselves again, we're going to calculate our own vector just to avoid weirdness. All right, even though vector will almost certainly be the same thing. So, okay. And then we're just going to be, technically speaking, we might double process some boxes. Given the size of the map, I don't care, and I'm not going to try to optimize it out by memoizing it if both of them are pointing at the same box. We just might double process boxes sometimes. Okay, so coord vector is the step in that direction. Now what we need to say here is, and this isn't quite going to be the same. All right, we have coord target. All right. My target equals add box half vector, coord other target equals add other half vector. Great. So now the question we need to ask is if we push either of these, do they find a wall? Or another box. So if so actually let's go here. So yeah, now what we just want to do here is return. So actually no. I want to minimize the amount that we process once we've discovered that something's not valid. All right. So I think what we just want to do here is, actually, you know what? Let's just do this. Switch map at my target, and we're gonna do this switch using a tuple. Map at other target. Okay. So now, if it's if there is a hash here and anything here, return false. Or sorry, it's just gonna be, or no. Oh right, this is that kind of a switch. This isn't a song. It's a lovely audio experiment. It isn't a song. Let's listen to some different orbital. That is a song. Okay. So here we are. We have the map at my target. We have the map at the other target. And now, if we take this thing, we go to here. Right, I'm going to change the syntax this week. We're going to say x return this thing switch. All right. So if there is a wall in front of my target, if there is anything and here, yeah, I'm just going to format these for some readability here. All right. If there's a wall at the other target, false. Then if there is if it is dot true. Otherwise, if it's not a wall and it's not an open, and we really shouldn't be pushing the bot at ourselves, otherwise, at this point, the question is going to be, dot and anything is going to be can move in direction. The box half is going to be other target direction. Or it's I'm anything, which means I'm going to be a box, and the other half is empty. Can move in direction my target direction. Or they're both something unforeseen, which means it's a box, which means it's can move in direction my target direction and can move in direction other target direction. Okay, so there we go. And I do like I like how this sort of pattern matching works here. It's just like, okay, if either one's a wall, great. If both of them are spaces, great. If one of them's a space, we have to look at the other one. If neither of them's a space, welp. All right, so now we've got can move in direction. So now the question we need to ask here is, if can move in direction right, it's going to be target, comma, direction. All right, so now we just need to figure out how we're going to execute that move. And again, this is going to be a little bit of a recursive mess. Well, actually, no, it's not so bad. Because it actually can be fairly similar to this. To the extent that I am going to copy this. So the thing here that we do need is if we are pushing. Actually, no, I think we can make this happen very similarly. Okay. All right. So now we know that we can move in the direction. Now we're going to say move in direction. And it's going to be void move in direction. Okay. Just return if you treat that. Okay. So now what we need to do here so we've still got this thing, and we've still got this sort of pattern here. We're going to actually need to do the switch the other way because we can't use an expression switch here. So we're going to switch on that. And it's going to be, case. Okay. And so we know that we're safe to do this, but we need to look at exactly what's above us. Okay, so... Oh, thank you, Polymathic Man. Good reminder. Let me, I have my fine nectarine lemon polar seltzer for hydration. And having hydrated, actually, My body informs me I also need to unhydrate, so I will be back in just a moment. We'll take a very quick little break, and then we'll be back to work on this. Thank you for that reminder. Back in just a few seconds. All right, we're back. Additional hydration. Okay, so what we want to figure out here is we have my target and we have other target. So the first thing I want to look at here is yeah, case so all right. We're now looking at what happens when actually I guess we kind of need to know whether we're the left half or the right half. So what we need to do here is this is going to be a little bit different. Instead of just caring about the other half, I need to know which half we are. So, oh, easy to do here. Easy to do. Okay, so coord. This is going to actually be a pair of coords. Coord left half toward right half. Yep. Equals map at box half, switch. So hang on. Can I firstly convert type int? Right. Yep. Okay, so now here we go. So if we are this thing, then the left half is going to be box half, comma, box half C+1. Otherwise, we're the right half, and the C-1 and comma, box half. Oh, I guess I do need to parenthesize these things so that they don't get confused. So what we're doing here is now we have two variables. Now we always know that that in left half is the one that has the left thing. So that's going to be helpful down here as we say map at left half, map at right half. Okay. So now the first case that we might have is, let's look at the case where we are pushing, or actually, I guess it's going to be, sorry, not left half, map right half. That's going to be that. It's going to be, I need left target, and actually, let's go with, yeah, just L target and R target. So add left half to vector, or add right half to vector. All right, and now we're going to switch based on what's at the L target and what's at the R target. All right. So if this is the case, there is only one block to be dealt with. So actually what I'm just going to do here is, yeah, let's kind of run through our cases here. And we'll just take a break there so that it doesn't yell at us. All right. If this is the case, we have kind of the inverse things there. Otherwise, if this is the case, otherwise, there's only two other options, which is this case and because, yeah, if a right side were here, it would have to be paired with that. So that would not be okay. So there we go. We can do each of those. So we've got a set of options now for what each of these cases can do, which is, in this case, we need to move in direction. So first we need, basically, we're going to move the stuff that is further away first, and then we're going to, clear our own path here. So to move, we're going to move in direction. Oh, actually, I guess, right, move in direction. Actually, I guess, yeah, the other thing we've got, right, that, or there's another case we need to care about. Case, quote, dot, which is the easy case. So to do that, this one here, we're going to simply, right, and then break after each of these. So we're going to move in direction. The thing that needs to move there will be, it could be either of L target or R target. We'll just choose L target direction. If it's this one, we need to do both of them. Okay. If it's this one, we just need to move the L target again. If it's this one, we just need to move the R target again. And finally, if it's this one, we actually don't need to do anything because we're about to move ourselves up into the space. So then, having done all of that, we just need to say swap left half L target and swap right half R target. Now, there's all kinds of scenarios we're not covering, but those should have all been covered by the can move in direction having said we're okay. So let's see what happens if we do this. Move in direction, target direction. I mean, I'm looking at this I'm looking at this mildly terrified, but I think it just might work. And if it is, I'm loving what this has done in terms of like the pattern matchers here. Okay, so we're going to start here. Program dot take 10 because I want to look at these. I want to look at like 10 of these manually. Okay, invalid operation exception. No robot. Oh, my big map never got cloned, did it? Sure didn't. We need to rebuild the big map. And then I need to make sure that we actually clone the big map when we're doing this here. We cloned it before. Where's my little happy cloney thing there? It was when I made the state, wasn't it? Yep. Okay, so there we are. So there's our thing. After that step, it moves. We move. Yep, we move down one. We move down again. We move over. We move up. Move over. We move down. Move up. Move over. Move down. Man, that really just dances around, doesn't it? Not making pushes. Take 20? There, it moves down, over. Yeah, okay, like, yeah, it pushes sideways, but I'm looking for any vertical pushing that it might do here. Okay, it moves down. It does not move down again. It moves over, over, moves over again, moves up, moves over again, moves down, moves up, down, over,